Soil swelling and shrinkage, causes and remedies. Have you ever noticed cracks in walls, uneven floors, or tilting fences in homes and buildings? These could be signs of a hidden ground problem, swelling and shrinking soils. In geotechnical engineering, this issue is more common than you might think, and if left unaddressed, it can cause serious structural damage. Let's dive into what causes soil swelling and shrinkage, and most importantly, how engineers deal with it. What is soil swelling and shrinkage? Soil swelling and shrinkage refer to the expansion and contraction of certain soil types due to changes in moisture content. When water enters the soil, it absorbs the moisture and expands. This is swelling. When it dries out, it contracts. This is shrinkage. This repetitive cycle can place stress on any structure built on or within it. Over time, this movement leads to structural instability, cracking, or even failure. Why does it happen? The key factor behind swelling and shrinkage is the presence of clay minerals, especially expansive clays like montmorillonite. These clays have a high affinity for water and can expand significantly when wet and shrink drastically when dry. Climate also plays a major role. Soils in areas with alternating wet and dry seasons are especially prone to this behavior. Poor drainage, leaking pipes, and landscaping that traps water near foundations can make the problem worse. How it affects structures. When the soil beneath a building swells, it lifts the foundation unevenly, causing floors to bulge and walls to crack. During shrinkage, the foundation may settle or sink, creating gaps and instability. This movement is called differential settlement, and it is especially problematic for rigid structures like concrete slabs or masonry walls. Roads, pipelines, and retaining walls can also deform or crack due to seasonal soil movement. Signs to watch out for. Some common signs that indicate swelling or shrinking soil include cracks in walls, especially at corners or around windows, doors and windows that stick or don't close properly, gaps between floors and walls, uneven or heaving concrete slabs, tilting fences or garden structures. If you notice these, it's important to investigate the soil conditions before the problem worsens. Engineering solutions and remedies. There are several ways to manage and prevent the effects of swelling and shrinkage. Soil replacement. Removing the expansive soil and replacing it with stable material is one option, though often costly. Moisture control. Installing proper drainage systems, gutters, and landscaping can keep water away from foundations. Chemical stabilization. Adding lime or cement to expansive soils can reduce their swelling potential by altering their properties. Underpinning. Strengthening the foundation using piers or piles that transfer the load to more stable soil layers below. Flexible structural design. Using flexible joints or reinforced slabs that can accommodate minor movement without damage. Each solution depends on the severity of the problem, soil type, and the structure involved. Preventive design practices. The best remedy is prevention through smart design. Site investigations and soil testing before construction help identify the risks. Engineers use tests like the plasticity index and shrink-swell index to determine a soil's expansion potential. Based on the results, they select foundation types that can either resist or adapt to soil movement, like deep foundations or floating slabs. Additionally, keeping vegetation and water sources away from the structure can significantly reduce long-term issues. Real-world examples. In areas like Texas, India, and parts of Africa, swelling soils are a common geotechnical challenge. Engineers in these regions often use moisture control barriers and foundation insulation to keep the soil's moisture content constant. Even major infrastructure like highways must be designed to resist cracking from seasonal swelling. Learning from these examples helps improve our understanding of soil behavior and guides future construction practices. Why it matters. Understanding soil swelling and shrinkage isn't just a technical concern. It affects the safety and longevity of homes, schools, and entire neighborhoods. As more land is developed and climate patterns become unpredictable, designing with soil movement in mind is essential. It's a classic example of how unseen forces below the surface can have massive effects above it. Thanks for watching. If you found this video helpful, give it a like and share it with others interested in civil engineering. Don't forget to subscribe to the channel for more deep dives into the world of soil mechanics, structural design, and everything civil engineering. Your support helps us build stronger knowledge, one layer at a time.